So imagine a help desk administrator, right? They're trying to offboard an employee who just resigned.
Yeah, standard IT ticket. Happens every day.
Exactly. So they log into the portal, they find the user's device, and they go to click the button to remove the corporate data. But they click the wrong button.
Oh, no.
Yeah. Instantly, this command is sent over the air, and it just completely wipes the user's personal smartphone.
Like factory reset.
Factory reset. We are talking years of irreplaceable family photos, personal text messages, unbacked up authenticator apps, all permanently deleted.
And that is not just a bad day for the user. I mean, the legal fallout from that is massive.
Huge. It's a total disaster. And it's not hypothetical, It actually happens. So today, we are making sure you never make that mistake. Welcome to a special bonus episode in the admin study room.
We're stepping away from the standard format today, right?
Yeah, exactly. We are focusing specifically on these really complex, high-stakes decisions you have to make when you're managing modern endpoints. And I should mention right at the top, I am your AI host, Jamie, and alongside me is my AI co-host and resident architecture expert, Alice.
That's right. And, we might be artificial intelligence, but the configuration nightmares and the security architectures we're dissecting today are very, very real.
They really are.
Endpoint administration has just evolved so much. I mean, it used to be just pushing software over a local network. Now, you're orchestrating identity, security, privacy, all across this borderless cloud-first environment.
It's a completely different job now.
It is. So we're looking at scenarios today that test not just, your knowledge of where a specific setting lives in a menu, but your understanding of how all these underlying systems actually interact with each other.
But before we get into the mechanics of all that, we do have a mandatory piece of housekeeping to read. This is an independent, unofficial MD-102 study podcast based on Microsoft's public learn content. It is not affiliated with, authorized, sponsored, or approved by Microsoft.
Perfect. With that covered, let's explain how this bonus episode is actually going to work.
Yeah, so we are running a pop quiz format today. We're basically going to take turns throwing 11 complex, multiple-choice scenario questions at each other, and all of this is based on Microsoft's public learning content. We've got your study guide right here.
But we aren't just going to, read the question, give you the correct answer, and move on. That doesn't really help you understand the why.
Right, no rote memorization here.
Exactly. We're going to tear down the architecture of every single option. We want to look at the exact mechanisms of why the right answer works. And honestly, perhaps more importantly, we want to look at under what specific alternative conditions the wrong answers would actually be the right tool for the job.
Because that's what forces you to think like an architect instead of just an operator. I mean, out in the field, you rarely get a help desk ticket asking you to define an acronym.
Yeah, no one submits a ticket saying, please explain OMAURI to me.
Right. You get tickets demanding a solution that balances user friction with zero trust security. Analyzing those constraints is where the real engineering happens.
So let's get right into the engineering then. I'm putting you in the hot seat first.
Bring it on.
All right, question 1. We are starting at the absolute foundation of device management, which is identity. Here is the scenario. A company is rolling out a fleet of new corporate-owned Windows laptops. The IT director has mandated a complete move away from on-premises Active Directory and group policy. Their explicit goal is to manage everything centrally through the cloud, minimizing legacy infrastructure.
Okay, pretty common mandate these days.
Right. So which join type is the most appropriate for these new devices? Here are your options. A, Entra-registered, B, Entra-joined, C, Entra-hybrid joined, or D, ADDS domain joined.
Okay, the constraints here really dictate the architecture. The correct answer is B, Entra-joined.
Unpack that. Why is that the only option?
Well, to fully map out why, we have to look at how these identity planes actually communicate. The scenario gives us 3 really strict parameters, right? The devices are corporate-owned, the company wants zero reliance on on-premises Active Directory, and they want a cloud-first management model.
Right, they want to cut the cord.
Exactly. And Entra-joined is literally the only option that satisfies all 3 of those. When a device is Entra-joined, its primary identity authority is Microsoft Entra ID in the cloud. It authenticates using a primary refresh token or a PRT directly against the cloud directory.
So there's no domain controller involved at all?
None. There is absolutely no requirement for a local domain controller to be reachable.
Okay, but let me push back on that for a second.
Yeah.
Put yourself in the shoes of a sysadmin who has spent, the last 10 years building these intricate, highly customized group policy objects. Option C, Entra hybrid joined, sounds like the ultimate safety net, doesn't it?
Oh, it sounds super appealing, yeah.
Because you get the new cloud identity, so you can use Intune, but you also get to keep your on-prem Active Directory domain controller and all those legacy GPOs.
Yeah.
If an organization is transitioning, why wouldn't they default to hybrid so they don't have to rebuild all their policies from scratch?
I see this argument all the time, but treating hybrid as a default safety net is just a massive architectural misstep. It introduces severe dependencies.
Like what?
Well, if a device is intra-hybrid joined, the authoritative source of truth for that computer object is still the local on-premises Active Directory. The object is created locally first, and then a service called Entra Connect Sync has to replicate that object up to the cloud.
So there's a sync delay right off the bat.
Yeah, but more importantly, this means the device requires a line of sight to a local domain controller to authenticate for the first time, to process group policy, and to rotate its machine password.
And if that line of sight is broken, like say the user takes the laptop home and hasn't connected to the VPN yet?
Exactly. You start running into trust relationship errors, the device gets confused. Plus, if the stated goal of the organization in our scenario is to move completely away from on-premises AD, hybrid just anchors them to the exact infrastructure they're trying to decommission.
Right, it's tying them to the sinking ship.
It's not the best of both worlds, which is what people always say. It's a bridge. It is meant for organizations that have legacy applications heavily dependent on Kerberos or NTLM authentication that they simply cannot modernize yet. But if you have the luxury of a pure cloud mandate, you go Entra-join.
That significantly clarifies the danger of option C. Obviously, option D, the traditional ADDS domain join, is completely out of the question because it offers zero cloud identity natively.
Right, that's a legacy way.
But that leaves option A Entra-registered. How does the architecture of Entra-registered differ from Entra-join?
So it really comes down to the concept of device ownership and the depth of cryptographic trust. Entra-registered is architected almost exclusively for BYOD.
Bring your own device.
Exactly. Think of a user wanting to check Microsoft Teams on their personal iPhone, or maybe their home gaming PC. When they sign in, the device is registered with Entra ID. The cloud directory creates a record of the device, and it issues a certificate to it to prove its identity during conditional access checks.
But the company doesn't own the device.
Precisely. The user logs into their operating system with their personal local account, or their personal Apple ID, or their personal Microsoft account. The corporate identity basically just sits on top of the device, and it's usually restricted just to specific corporate applications.
Whereas Entra-joined goes deeper.
Right. Entra-join means the corporate identity is the primary login for the operating system itself. You boot up the Windows machine, and right there at the lock screen, you type in your organizational credentials. Because the scenario specified corporate-owned laptops, Entra-registered would be a totally inappropriate, weakly managed state.
That makes perfect sense. Entra-joined establishes that deepest level of cloud-native trust. Okay, so we've established the identity when a device is brought into the environment.
Right, the onboarding phase.
But the device lifecycle eventually ends, or at least the user's relationship with the company ends. Let's look at offboarding, which actually takes us right back to that disaster scenario you mentioned in the introduction. So it's your turn to ask.
All right, let's examine that exact disaster. Here's the scenario for question 2. An employee is leaving the company, but they are keeping their personally owned smartphone, which they've been using to access corporate data. You need to remove the company's data from that phone, but you absolutely must not delete their personal photos, personal applications, or local files.
A nightmare scenario.
Yes. So which remote action from the administrative center should you use? Your options are A, wipe, B, retire, C, delete, or D, autopilot reset.
Okay, the correct answer here is B, retire. And the distinction between these options is quite literally the difference between a routine IT task and a lawsuit.
Yep.
We are dealing with a BYOD mobile device, meaning the hardware belongs to the user. The IT department has only a localized management footprint on that device.
So let's analyze the mechanics of option A, wipe. What actually happens at the firmware level when an admin triggers a wipe command on a phone?
Well, when you issue a wipe command to a mobile device through an MDM platform like Intune, you aren't just like deleting files one by one. You are sending a command to the device's operating system to execute a crypto shredding operation.
Crypto shredding? That sounds aggressive.
It is. Modern smartphones encrypt the entire storage drive by default. The wipe command tells the phone to permanently delete the encryption key that decrypts the storage and then reboot, In a matter of seconds, every single byte of data on that phone, corporate and personal, is rendered mathematically inaccessible.
Wow.
And then the phone just resets to its factory out-of-box state.
Which, I mean, is necessary for a lost or stolen corporate-owned device, right?
Absolutely. If a company laptop is left in a coffee shop, you want that crypto shredding to happen immediately to prevent a data breach. But if you execute that on a user's personal phone just because they quit their job, you are destroying their private property. That is why option A is the absolute wrong answer here.
Makes sense. So option B, retire, is the surgical approach.
Yes.
So how does retire physically separate the corporate data from the personal data without touching the personal files?
It relies on how the management profile was installed in the first place. When a user enrolls a BYOD phone, the MDM payload creates a logical separation. Usually it's a managed container or a work profile. The corporate apps, the VPN profiles, the Wi-Fi certificates, the corporate email, all of that lives inside this managed partition.
Okay, so it's fenced off.
Right. So when you trigger the retire action, Intune essentially revokes the certificate communicating with that management profile. It tells the phone, delete the managed partition. The corporate apps vanish, the corporate data is purged, and the device is unenrolled from Intune.
And the personal side?
The personal side of the phone, where the user's photos and text messages live, is completely blind to this operation. It remains entirely untouched.
That surgical removal is crucial for BYOD. Now, what about option C, delete? Because I feel like I see administrators fundamentally misunderstand this action all the time.
Oh, constantly. It's a semantic trap. When an admin sees the word delete, they assume it means delete the data. But in the context of the Intune Admin Center, delete is an inventory action, not a device action.
Wait, what does that mean?
If you select a device and hit delete, you are simply deleting the record of that device from your administrative console.
You're just wiping it from your own screen.
Exactly. You are telling Intune to stop tracking it. It does not send a command to the device to remove any data whatsoever. If you just hit delete, that former employee walks out the door with all the corporate email and SharePoint files still perfectly accessible on their phone. You've just blinded yourself to it.
That is terrifying. Okay, and what about option D, Autopilot Reset?
Architecturally irrelevant to a mobile phone. Autopilot Reset is a very specific Windows OS command. It's used when you want to take a corporate-owned Windows device, scrub the primary user's data and installed apps, but maintain the device's Entra ID, joint state, and Intune enrollment.
So you can just hand it straight to the next employee.
Exactly. You can't run an Autopilot Reset on an iOS or Android device. It just doesn't apply.
The precision of these remote actions is unforgiving. You really have to understand the payload you are sending. This brings up an interesting architectural challenge, though. If BYOD devices represent such a massive liability regarding data commingling, how do we actually protect the data while the employee is still active without taking over their entire personal device?
That is the million-dollar question. Let's move to question 3. I've got this one. Here's the scenario. You need to ensure that users cannot copy sensitive text from their corporate Outlook application and paste it into their personal unmanaged Apple Notes or Google Keep application on a BYOD device. Which policy should you implement to stop this data leakage?
Oh, this is a good one.
Options are A, App Configuration Policy, B, App Protection Policy, C, Conditional Access Policy, or D, Device Compliance Policy.
Okay, this targets the exact friction point between user privacy and corporate security. The correct answer is B, App Protection Policy. And this is the foundational tool of mobile application management, or M.
So let's break down the architecture of MAM versus traditional MDM, mobile device management. Why wouldn't we just enforce an MDM policy that restricts clipboard access across the entire operating system?
Because enforcing a system-wide restriction on a personal device violates the core contract of BYOD. If you force an employee to enroll their personal phone into full MDM, yes, you gain the ability to restrict the OS-level clipboard. But you also gain the ability to see their app inventory, track their location, and, as we just discussed, accidentally wipe their entire device.
Right. Users will aggressively resist full MDM on personal hardware. I know I would.
Same. So mobile application management changes the boundary of trust. Instead of managing the device, we manage the application sandbox itself.
How does that sandbox actually intercept a copy-paste command, though, at the OS level?
It uses application wrapping or integration with the Intune SDK. Let's take the Outlook app as an example. When a user downloads Outlook from the public app store, it's just a standard app. But when they sign in with their corporate Entra ID credentials, the app protection policy is delivered directly to the application.
Okay.
The policy creates an encrypted logical boundary around the corporate data, and it literally hooks into the operating system's clipboard API. So when the user highlights text in a corporate email and selects copy, the MAM policy encrypts that copied data in the device's memory.
Interesting.
If a user switches to another managed app, like say Corporate Word, the policy decrypts it and allows the paste.
But if they switch to an unmanaged app?
If they switch to their personal Apple Notes and hit paste, the MAM policy recognizes that Apple Notes is outside the trusted application boundary. It refuses to release the decryption key for the clipboard data, so the paste action simply fails, or maybe it pastes the notification saying, your organization's data cannot be pasted here.
That's brilliant.
And the beauty of this is that the user can still freely copy and paste between their personal text messages and their personal notes.
Oh,
We only govern the corporate data.
that is a phenomenal breakdown of the mechanism. Now let's analyze the traps and the wrong options. Option A, app configuration policy. Administratively, app protection and app configuration sit right next to each other in the Intune console.
So what is the fundamental difference in what they do?
It's simple. App protection secures the data, app configuration dictates the setup and behavior, and app configuration policy delivers an XML or JSON payload to an application to pre-configure it so the user doesn't have to.
Give me an example.
Like, if you deploy a proprietary line of business app, you might use an app configuration policy to inject the internal server URL or maybe hide a specific settings menu within the app. It manages the application's preferences, not its cryptographic boundaries. You cannot use an app config policy to prevent data exfiltration. Got it. And what about option C, conditional access? We hear so much about conditional access being the ultimate security tool. Why can't it block the clipboard?
Because of where it sits in the network architecture. Conditional access evaluates the authentication token at the perimeter. When the user opens Outlook and tries to download their email, conditional access evaluates their identity, their location, and their device state, and it makes a binary decision, block access or grant access.
But once access is granted,
Exactly. Once access is granted and the email is downloaded into the Outlook app, conditional access's job is done. It has absolutely no visibility into what the user does with the data locally on the touchscreen. Conditional access guards the front door. App protection policies guard the data once it's inside the house.
that is a great way to separate the perimeter from the endpoint. And option D, device compliance policy, is purely an evaluation mechanism. A compliance policy checks if the device meets health requirements, like having a minimum OS version or checking if it's jailbroken, but it doesn't enforce application-level restrictions itself.
Precisely. So ALM handles the software boundaries beautifully on personal mobile devices, but what about provisioning entirely new hardware for corporate use?
Windows deployment.
Let's shift our focus to Windows deployment architecture. My turn to ask you question 4.
Ready?
Here's the scenario. During a Windows Autopilot deployment, you want to prevent the user from accessing the desktop until all critical security policies and core applications are fully installed. Which feature controls this restriction? A, out-of-box experience, or OOBE customization. B, subscription activation. C, enrollment status page, or ESP. Or D, provisioning packages.
Okay, the correct answer here is C, the enrollment status page. To really understand the gravity of this feature, we need to trace exactly what happens during a modern autopilot provisioning sequence.
Walk me through it.
When an employee unboxes a new Windows device, connects to Wi-Fi, and enters their corporate email, the device recognizes its hardware hash in the Autopilot deployment service. It bypasses the standard consumer setup and begins pulling down the corporate configuration. If you do not have the ESP configured, the user experience seems incredibly fast. They enter their password, and within a minute, they are staring at the Windows desktop.
Which, from a user satisfaction standpoint, sounds fantastic. They can immediately open the Start menu and get to work. Why is that a problem?
It is an architectural vulnerability of the highest order.
Really?
Yes, because when they hit that desktop, the Intune management extension is likely still downloading and processing policies in the background. That means the user have active, unhindered access to the operating system before the Microsoft Defender policies have enforced firewall rules, before the BitLocker policy has initiated drive encryption, before the third-party endpoint detection and response, the EDR agent has actually installed.
Oh, wow.
You have a user with a web browser operating on a fundamentally unprotected, unmanaged machine. They could download a malicious file or plug in an unauthorized USB drive, and the security stack just isn't there to stop them yet.
That is a huge gap. So the ESP acts as a hard gate. How does it technically function during the boot process?
The ESP hooks into the first sign-in animation phase. It physically takes over the graphical interface of the screen, replacing the desktop with a tracking overlay. It divides the provisioning process into 3 phases: device preparation, device setup, and account setup.
Like a progress screen.
Exactly.
Yeah.
And as the administrator, you configure the ESP profile to say, do not release this screen lock until these 5 specific critical applications like our VPN client and our antivirus agent return a success code. The user is forced to sit and watch the progress bars until the machine is verifiably secure. Only then does the ESP drop, granting them access to the Explorer shell.
That makes the ESP non-negotiable for a zero-trust deployment. Let's look at why the other options fail to provide this. Option A, OBE customization. OBE is the out-of-box experience. Autopilot heavily modifies OBE, so why doesn't OBE customization handle the desktop lock?
Because OBE customization is primarily cosmetic and flow-based. It dictates what the screens look like before the heavy installation phase begins. You use OBE customization to apply your company branding to the sign-in page. You use it to automatically accept the end-user license agreement so the user doesn't have to click it.
And hiding privacy prompts, right?
Most importantly, yes. You use it to suppress the consumer privacy screens asking about Cortana or location services or diagnostic data. OBE customization streamlines the clicks, but it does not evaluate policy installation state or lock the desktop.
Okay, and option B, subscription activation.
That is purely a licensing mechanism. A manufacturer might ship a laptop with an OEM license for Windows 11 Pro. When the user signs in during Autopilot, Entra ID checks their user license. If they have a Microsoft 365 E5 license, subscription activation silently injects a new product key and steps the operating system up from Windows Pro to Windows Enterprise to unlock advanced features like Credential Guard.
Ah, so it's just a background upgrade.
It happens transparently in the background and has nothing to do with blocking the user interface.
Let's touch on option D quickly. Provisioning packages.
Provisioning packages, or not PPKG files, are a completely different deployment methodology. You create them using the Windows Configuration Designer, put them on a USB flash drive, and physically plug them into a machine during the OBE screen. They inject configuration payloads locally.
So useful for offline setups.
Right. They're useful for bulk enrolling shared devices in a warehouse where Wi-Fi is spotty, but they aren't a cloud-native autopilot mechanism for tracking application installations and holding the desktop state.
Excellent teardown. So the device is enrolled, the ESP has ensured the core security apps are installed, and the user is finally on the desktop. Now, the device needs its ongoing configuration, but deploying policies efficiently at an enterprise scale requires extreme precision. Let's dig into targeting strategies with question 5.
All right, here is your scenario. You have created a Wi-Fi configuration profile that you have assigned broadly to a group called All Corporate PCs. However, you realize that due to driver compatibility, you only want this specific Wi-Fi profile to apply to devices running a highly specific OS version within that massive group.
Okay.
What is the most efficient way to achieve this targeted deployment without redesigning your entire Entra ID group structure? Options. A, create a new security group specifically for that OS version. B, use a dynamic membership rule that mixes users and devices. C, use assignment filters. Or D, import an ADMX-backed policy.
The operative word in the scenario is efficient. The correct answer is C, use assignment filters. The architecture of how policies are delivered to endpoints relies heavily on the evaluation engine. To understand why filters are the right choice, we have to look at why option A, creating a new security group, is architecturally inefficient at scale.
Right. If I need to target Windows 11 machines, why not just make a dynamic security group called Windows 11 Devices and assign the policy to that?
You certainly could, and historically that is exactly what administrators did. But it leads to a phenomenon known as group sprawl. Imagine you have different Wi-Fi policies for Windows 10, Windows 11, iOS, and Android. Then you have different VPN policies for laptops versus desktops.
It adds up fast.
It does. If you create a unique Entra ID dynamic group for every single permutation of policy targeting, you end up with hundreds of interlocking, overlapping groups.
And what is the technical penalty for having hundreds of dynamic groups?
Compute time and sync delays. Entra ID dynamic groups rely on a back-end evaluation engine. When a device checks in or updates its properties, the Entra ID engine has to query the Graph API, look at the device's attributes, evaluate it against the syntax of every single dynamic group, and then add or remove the object.
So that's all happening on the cloud side.
Yes. And in a large enterprise, that evaluation process can take hours. If a machine upgrades its OS, it might not fall into the correct dynamic group until the next day, meaning it doesn't get the necessary policy immediately.
That latency is unacceptable for security policies. So how do assignment filters bypass that back-end evaluation delay?
Assignment filters fundamentally change where the evaluation happens. Let's look at this scenario. You assign the Wi-Fi policy to a massive static group, all corporate PCs. That assignment is simple and fast. But then you attach a filter to the assignment that says, include only if OS version starts with 10.0.22621.
That's a Windows 11 build number.
Exactly. So when the device syncs with Intune, Intune looks at the group and says, yes, you are in the broad group. Here is the policy payload. The payload comes down to the local machine. The Intune management extension agent on the local device evaluates the filter in real time against its own local property.
Oh, so the device does the math.
Yes. If the local OS version matches the filter, the agent applies the policy. If it doesn't match, the agent reports the policy as not applicable and skips it. The evaluation is instantaneous and localized, requiring zero backend group calculations from Entra ID. It allows you to use massive, simple groups while achieving surgical precision at the endpoint.
That is the ultimate definition of efficiency. Now, I want to look closely at option B. Using a dynamic membership rule that mixes users and devices, Microsoft Learn explicitly warns against this. What happens if you try to build a group that way?
The Entra ID logic engine will simply fail. A dynamic group must be homogeneously scoped to either user objects or device objects. You can create a rule evaluating user attributes like user.department equals sales, or you can evaluate device attributes like device.deviceOS type equals Windows.
Do not both.
Never both. If you try to write a syntax that says user is sales and device is Windows, the system cannot resolve it because an individual object evaluating the rule is either a user or a device. It can never possess both sets of attributes simultaneously.
So it's structurally impossible. And option D, importing an ADMX-backed policy.
That is confusing policy creation with policy targeting. ADMX ingestion is the process of taking the administrative template files used for traditional group policy and importing them into Intune so you can configure third-party apps like Google Chrome or Mozilla Firefox. It dictates what the policy configures, but it has absolutely no bearing on how that policy is targeted or filtered to specific devices.
Perfect explanation. So filters give us localized, real-time precision. But precision requires knowing exactly what settings to configure. What if you don't want to engineer every setting from scratch? What if you just need a secure baseline? That brings us to question 6. My turn to ask.
Go for it.
Here is the scenario. You are tasked with rapidly standardizing the secure configuration of 500 new Windows devices to a Microsoft-recommended starting point. You need to achieve this broad hardening before you tweak any individual specific organizational settings. Which approach provides the most efficient foundation? A, deploy a custom OMA URI profile. B, deploy a security baseline. C, configure an attack surface reduction, or ASR, policy. Or D, use endpoint privilege management, or EPM.
The correct answer is B, deploy a security baseline. And the architectural reason for this goes back to the sheer volume of configurable parameters in the Windows operating system. If you open the settings catalog in Intune, you're looking at thousands upon thousands of individual registry toggles.
Right, everything from complex firewall rules to obscure credential guard configurations.
Exactly. If you were tasked with securing 500 machines, you could theoretically read through the Center for Internet Security benchmarks, open a blank configuration profile, and manually toggle 300 different settings. It would take days, and the risk of human error, missing a crucial setting, or misconfiguring a cipher suite is incredibly high.
So baselines solve this.
Yes, a security baseline is a pre-packaged, Microsoft-curated bundle of settings. Microsoft's security engineering teams constantly update these baselines to reflect the current threat landscape. Deploying a baseline is essentially a one-click deployment that stamps the industry-standard secure configuration across the entire OS footprint. It saves an immense amount of administrative overhead.
But let me challenge the deployment of baselines, because they are notorious for causing conflicts in complex environments. If a baseline configures hundreds of settings under the hood, what happens when an administrator tries to deploy a separate, highly targeted policy for, say, Microsoft Defender antivirus?
You hit the classic Intune conflict scenario. Intune operates on a deterministic conflict resolution model. If a security baseline dictates that Defender must run a quick scan every day at noon, and a separate standalone antivirus policy deployed to the same machine dictates that the scan must run at 2 p.m., Intune detects the clash.
And it picks the newer one.
No. Because both policies have equal weight, Intune will not guess which one you prefer. It marks the setting in an error state as a conflict, and neither policy is applied to that specific setting.
That's a mess. So how does an architect handle that? Do you just not use baselines if you need custom policies?
You use the baseline, but you customize its payload. When you deploy a baseline, you have the option to review every setting inside it. If you know you are managing your Defender antivirus settings with a dedicated endpoint security policy, you go into the baseline profile and change all the Defender-specific settings from their default values to not configured.
Wait, doesn't not configured just turn it off?
A lot of people think that, but no. Not configured means Intune will not manage this setting via this policy. This removes the overlap and allows the standalone policy to apply cleanly without conflict.
That is a critical best practice. Now, let's dissect the wrong options. Why not option A, deploy a custom OMA URI profile?
Because OMA URI is the absolute inverse of efficiency. OMA URI stands for Open Mobile Alliance Uniform Resource Identifier. It is the underlying protocol that Intune uses to communicate with the Windows Configuration Service Provider, or CSP.
So it's basically the raw code.
Basically. When a new feature is released in Windows, it sometimes takes a few months for Microsoft to build a nice graphical toggle for it in the Intune portal. In the interim, an admin can create a custom OMA URI profile where they manually type the exact XML or string payload to manipulate the registry key directly.
It's not prone to typos.
Highly complex, prone to syntax errors, and is used strictly as a localized workaround for obscure settings. You would never use it to deploy broad, standardized security hardening.
And option C, attack surface reduction, or ASR. That sounds like a security hardening tool.
ASR is a vital security tool, but its scope is highly targeted, not foundational. Security baselines manage the overall posture of the OS passwords, firewalls, idle locks. ASR policies act as a surgical defense against specific malware exploit techniques.
For example,
An ASR rule might specifically block Microsoft Office applications from launching child processes, which is a classic macro-based ransomware technique. Or it might block executable files from running unless they meet an age and prevalence criteria. ASR is about restricting application behaviors, while baselines are about OS configuration.
Okay, and option D, endpoint privilege management, doesn't harden the OS at all. It just governs user rights, which actually transitions us perfectly to question 7. Hardening the OS is essential, but if an attacker compromises a privileged account, the OS hardening can often be bypassed. It's your turn to ask.
Let's talk about the ultimate skeleton key, local admin rights. Here is the scenario. You need to secure the built-in local administrator account on your managed Windows devices. Your explicit requirement is to ensure the password for this account is automatically rotated on a schedule and that the password is mathematically unique for every single device in the fleet.
Okay, unique and rotating.
Yep. Which feature provides this capability natively? A. Windows Hello for Business. B. Endpoint Privilege Management, or EPM. C. Windows LAPS. Or D. Microsoft Entra ID Protection.
The correct answer is C, Windows LAPS, which stands for Local Administrator Password Solution. To truly appreciate why LAPS is a non-negotiable architecture standard today, we have to talk about the historical nightmare of the shared local admin password.
Walk us through how imaging used to work regarding local accounts. I know it was pretty bad.
10 or 15 years ago, an IT department would build a master image for their laptops. Part of that image included enabling the built-in local administrator account, so the help desk would always have a backdoor to log in if the machine dropped off the domain.
Right.
And to make things easy for the help desk team, the sysadmin would set the password for that account to the exact same string across the entire fleet. Let's call it help desk 2024 bang.
And that scales easily. The tech just remembers one password. What is the catastrophic risk there?
The risk is a lateral movement technique known as pass the hash. If a user clicks a phishing link and an attacker compromises just one single laptop, the attacker dumps the local SAM database on that machine. They extract the cryptographic hash of that helpdesk 2024 password.
But it's hashed, right, so they can't just read it.
They don't need to read it. The attacker doesn't even need to crack the hash to know what the plaintext password is, because every single laptop on the corporate network shares that exact same local admin password. They all share the exact same hash. The attacker simply passes that hash to the next laptop, authenticates as the local admin, and moves laterally across the entire network. They can compromise thousands of machines in minutes.
It's the definition of a single point of failure. So how does the architecture of Windows LAPS eliminate that lateral movement risk?
LAPS completely automates the password generation and storage process. When LAPS is deployed via Intune, The Intune policy commands the local Windows operating system to randomly generate a highly complex, unique password, say 16 characters of random alphanumeric symbols. The OS sets that as the local admin password. But crucially, the device then securely encrypts that password and escrows it up to Microsoft Entra ID.
It stores it in the cloud object.
Exactly. The local password is never known to the user, and it isn't statically recorded on an IT spreadsheet. When a help desk technician needs to troubleshoot a broken machine, they log into the Intune portal, look up that specific device object, and request to view the LAPS password.
And it audits that, right?
Yes. Entra ID logs an audit event that the tech viewed the password. The tech uses the unique password to fix the machine. Then, and this is the best part, LAPS automatically rotates the password. You can configure it to rotate every 30 days, or you can configure it to rotate immediately after the password is used. Every machine has a unique lock, and the keys are constantly changing.
That completely neutralizes the pass-the-hash attack vector. Now, let's analyze option B, endpoint privilege management. EPM is a relatively new capability in the Intune suite, and it frequently gets confused with LAPS because they both deal with the concept of administration. What is the fundamental architectural difference?
It comes down to who is doing the administrating. LAPS manages the account that the IT department uses. EPM manages the tasks that the end user performs.
Okay.
In a zero-trust environment, standard employees should never have local admin rights. But sometimes, a standard user needs to run a legacy accounting application that requires an administrative token to launch, or they need to install an approved printer driver.
And historically, IT would just give them local admin rights to stop the help desk tickets.
Which destroys your security posture. EPM allows you to maintain the user as a standard non-privileged account. But you are at an EPM role that says, when the user double-clicks this specific cryptographically signed accounting executable, temporarily elevate the process. The application runs with administrative privileges, but the user does not possess the administrative password. LAPS is for IT access. EPM is for user elevation.
That is a phenomenal distinction. What about option A, Windows Hello for Business?
Windows Hello for Business is an authentication mechanism for the user's primary Entra ID account, not the local admin account. It replaces passwords with a cryptographic peon or biometric marker tied to the hardware TPM chip. It is a massive security upgrade, but it doesn't rotate local admin credentials.
Okay, and option D, Entra ID protection.
That's a cloud-side telemetry engine that analyzes sign-in behavior to detect compromised identities, like impossible travel scenarios. Again, irrelevant to local account management.
Great breakdown. Now, all these zero-trust cloud-native architectures, Intune, LAPS, Autopilot, they represent the modern ideal. But enterprise IT is rarely ideal. So true.
Many organizations are still managing machines the legacy way, utilizing local servers and complex imaging sequences. Let's step back in time for question 8. The legacy world, I am ready. Here is your scenario. When utilizing the Microsoft Deployment Toolkit, or MDT, for on-premises bare metal provisioning, what is the primary architectural advantage of deploying a thin image rather than a thick image? Is it A, it deploys faster because all applications are pre-installed in the WIM file? B, it is easier to maintain over time because applications and updates are installed dynamically during the deployment sequence? C, it completely removes the need for PXE boot on a local network? Or D, it automatically joins the device to Entra ID without any user interaction?
Okay, the correct answer is B. A thin image is infinitely easier to maintain. To fully grasp this, we have to look at the historical thin versus thick debate that defines systems administration before the cloud era. It all centers around the WIM file, the Windows Imaging Format file.
Let's start with the thick image. To build a thick image, an administrator takes a physical reference computer. They install the base Windows OS. Then, they spend hours manually installing Microsoft Office, Google Chrome, Adobe Acrobat, VLC Player, custom line of business apps, and every single Windows update.
Right, they build the perfect golden machine.
Exactly. Then they run a tool called sysprep to generalize the machine, stripping out the hardware-specific identifiers. Finally, they capture that entire massive hard drive state into a single multi-gigabyte WIM file. When they deploy that thick image to a new laptop, option A is actually correct in the short term. It deploys very fast. You drop the massive file onto the disk, reboot, and the machine is fully loaded.
So if it deploys faster, why is it an architectural nightmare?
Because software ages rapidly. Let's say you build that perfect thick image on a Monday. On Wednesday, Google Chrome releases a critical zero-day security patch. Your massive thick image is now obsolete and actively vulnerable.
Oh man, the update loop.
To fix it, you have to boot up your reference machine, install the Chrome update, rerun sysprep, recapture the massive WIM file, and then replicate that 13 GB file across all your local distribution point servers. If you have applications updating weekly, you are spending your entire career rebuilding thick images.
It becomes an unsustainable maintenance loop. So how does the architecture of a thin image solve this?
A thin image takes the opposite approach. The WIM file contains almost nothing. It is literally just the base Windows operating system ISO and perhaps a few critical storage drivers. It is a tiny, bare-bones file.
Okay, so how do they get the apps?
When you deploy a thin image, you lay down the base OS, and then MDT utilizes a task sequence. The task sequence is an automated script that runs inside the newly installed OS. The script reaches back out to the MDT server and dynamically executes the installers for Chrome, Office, and Acrobat over the network in real time.
Which means the deployment takes significantly longer while the machine downloads and installs everything.
Yes, the machine might sit on the deployment bench for an hour, but the administrative maintenance is practically zero. When Chrome releases that zero-day patch on Wednesday, you don't rebuild the image. You just download the new Chrome MSI installer, drop it into the application folder on the MDT server, and replace the old file.
Why, that's it.
That's it. The very next time a task sequence runs, it dynamically grabs the updated file. The time saved in administrative maintenance vastly outweighs the extra time the machine takes to provision. Therefore, option B is the correct advantage.
That is a perfect encapsulation of legacy lifecycle management. Let's quickly invalidate the remaining options. Option C claims a thin image removes the need for PXE boot. PXE, or pre-boot execution environment, is the network protocol that allows a bare metal machine to find the deployment server and download the boot image.
And you need that regardless, right?
Right. Whether the final payload is thick or thin, you still need PXE to initiate the process over the network. And option D claims MDT automatically joins Entra ID without user interaction. MDT is fundamentally an on-premises tool designed to join traditional Active Directory domains. While you can script it to facilitate an Entra join, true zero-touch cloud enrollment without user interaction is the exclusive domain of Windows Autopilot self-deploying mode, not a native property of a thin image WIM file.
Excellent analysis. Now, as you pointed out, managing those application installation files, writing silent install scripts, managing detection rules is incredibly tedious, even on modern Intune. Microsoft recognized this pain point. How does the modern cloud architecture address app deployment today? That leads us to question 9, my turn to ask. Your organization is exhausted by the manual overhead required to package common Win32 applications. They want a standardized cloud-based workflow that allows them to select, deploy, and automatically update supported enterprise applications with minimal manual configuration. Which specific Intune suite capability solves this problem? Options: A. Enterprise App Catalog, B. Microsoft Cloud PKI, C. Microsoft Intune Advanced Analytics, or D. Microsoft Tunnel.
The correct answer here is A, the Enterprise App Catalog. To understand the immense value of this feature, we have to look at the architectural friction of deploying legacy Win32 applications through Intune. Modern UWP apps from the Microsoft Store are easy, but traditional .exe and .mai installers require significant engineering.
Let's break down that engineering. If I want to deploy a standard executable installer for an app like Zoom using traditional Intune, what are the steps?
It's a multi-step, highly manual process. First, you have to download the installer file. Then you have to download a command line utility called the Intune Win32 Content Prep Tool. You run the tool locally to encrypt and wrap the installer into a proprietary .intune win format. You upload that wrapped file to the Intune portal.
That's just the packaging.
Exactly. Then you have to manually research and type in the silent installation commands like /s or /quiet because every vendor uses different switches.
Yeah, that's a headache.
And finally, the hardest part. You have to construct custom detection rules. Intune needs mathematical proof that the app actually installed. You have to write a rule that says, check this specific file path or query this specific registry key hive to verify the application exists. If your detection logic is flawed, Intune thinks the installation failed and will continuously attempt to reinstall the app every time the device syncs.
It requires the administrator to act as a software packager. How does the Enterprise App Catalog fundamentally alter that workflow?
The Enterprise App Catalog is an add-on within the Intune suite that shifts the packaging burden entirely to Microsoft. Microsoft hosts a curated repository of common enterprise applications. Instead of wrapping files, you simply browse the catalog in the Intune portal, select the app you want, and Microsoft handles the backend.
Wait, they do all the wrapping?
Microsoft provides the pre-wrapped binaries, they inject the correct silent install and uninstall commands, and they pre-configure the exact vendor-approved detection logic. You just assign it to a group, and the catalog handles the deployment and the ongoing application updates. It turns a 1-hour engineering task into a 5-minute selection process.
That is a massive operational shift. Let's analyze the other Intune suite options to understand their architectural roles. What does option B, Microsoft Cloud PKI, actually do under the hood?
Cloud PKI is a revolution for certificate management. Historically, if an organization needed to issue certificates to endpoints, say a certificate to authenticate to a secure corporate Wi-Fi network or an always-on VPN, they had to stand up a complex on-premises infrastructure. They needed an Active Directory Certificate Services server, an NDES server, and a connector proxy. It was brittle and hard to maintain.
So Cloud PKI replaces all that.
Cloud PKI virtualizes that entire certificate authority infrastructure natively within the Intune cloud. You can issue SCEP certificates directly from Entra ID to the endpoints without a single on-premises server. It's brilliant, but it has nothing to do with application packaging.
And option C, Advanced Analytics.
Standard Intune telemetry is binary. Is the device compliant or non-compliant? Did the policy apply or fail? Advanced Analytics utilizes the Intune Management Extension Agent to gather deep system-level telemetry. It uses KQL queries and machine learning to analyze battery degradation, application crash frequencies, and boot times.
So it's for troubleshooting.
It allows IT to proactively discover that a specific graphics driver update is causing blue screens across a specific model of laptop before the help desk is flooded with calls. It's about proactive remediation, not app cataloging.
Finally, option D, Microsoft Tunnel.
Microsoft Tunnel is an architecture specifically for mobile devices, iOS and Android. It provides a micro VPN gateway. If an employee is using a managed Microsoft Edge browser on their personal iPhone and they need to access an internal corporate intranet site hosted on an on-premises server, Tunnel creates a secure, app-specific connection back to the corporate network. It doesn't connect the whole phone, just the managed app.
Excellent teardown. So we have the apps deployed, we have the OS hardened with baselines, and we are managing local admin access. The endpoint is secure. But how do we architect the perimeter to ensure that only secure endpoints can access our data? That brings us to question 10. Your turn.
This is where everything we've talked about culminates. Here's the scenario. You need to architect a zero-trust perimeter. Specifically, you need to block access to Microsoft 365 cloud services, like Exchange Online and SharePoint, if a device is lacking the required BitLocker drive encryption. How do compliance policies and conditional access architecture interact to enforce this restriction?
Okay, the options.
Options. A, conditional access evaluates the device hardware directly to block it. B, compliance policy defines the health requirements, and conditional access acts as the gatekeeper to enforce the block based on that health state. C, app protection policy checks the device, and Windows LAPS blocks the network. Or D, security baselines configure the device, and Intune roles block access.
The correct answer is B. This interaction is the absolute beating heart of the zero trust architecture. The concept of zero trust is never trust, always verify. To verify, you need two distinct systems communicating, an evaluation engine and an enforcement engine. I think the best way to explain this interaction is using the classic analogy of the doctor and the bouncer.
It is the perfect analogy. Lay out the roles for us.
Let's start with the compliance policy, which plays the role of the doctor. The doctor's job is to administer health examination. In Intune, you build a compliance policy with a specific checklist. Is the firewall active? Is the OS at the minimum required patch level? And per our scenario, is the OS drive encrypted with BitLocker?
And Intune checks that locally.
The Intune agent on the device performs local queries, checking the device health attestation state from the hardware TPM chip, and reports the results back to Intune.
But the doctor doesn't stand at the door.
Exactly. The compliance policy itself has no power to block network traffic or deny access to SharePoint. If a device fails the BitLocker check, the doctor simply writes a prescription note, a cryptographic state change, that updates the device object in Entra ID from compliant to non-compliant. That's the extent of the doctor's authority.
This is where the bouncer stepped in.
Yes. Conditional access plays the role of the bouncer at the front door of Microsoft 365. The bouncer doesn't know how to perform a medical exam. Conditional access cannot query a local hard drive to see if BitLocker is running. The bouncer only knows how to read the doctor's note.
I love that.
When the user attempts to open an email in Exchange Online, the request passes through Entra ID. Conditional access intercepts the request, evaluates the authentication token, and looks at the device's compliance state. If the conditional access rule is configured to require device to be marked as compliant and the device state is non-compliant, the bouncer drops the connection. The user is blocked.
It's a beautiful, decoupled architecture. Intune handles the deep OS-level hardware evaluation, and Entra ID handles the identity-level perimeter enforcement. They pass the signal via the Graph API. Let's look at why option A is architecturally incorrect. It states conditional access evaluates the hardware directly.
And that is a fundamental misunderstanding of the cloud boundary. Conditional access is an identity control plane. It evaluates IP addresses, user risk profiles, and token claims. It does not have an agent sitting on the endpoint interrogating registry keys. It relies entirely on Intune to supply the hardware telemetry.
Options C and D are essentially word salad, mixing up distinct technologies. App protection secures the M sandbox, and LAPS manages passwords. Neither blocks network traffic. Security baselines enforce settings, and Intune rules dictate what an administrator can click within the console. Neither act as a real-time perimeter gatekeeper. Option B is the only accurate description of the architecture.
So we've established the modern cloud-native zero-trust ideal. But let's look at the reality on the ground. You have Fortune 500 companies with 20 years of investment in on-premises configuration manager infrastructure. They cannot simply flip a switch on a Friday night and move 50,000 devices to this cloud-native Intune model. The risk of disruption is too great. How do they navigate that transition? That brings us to our final scenario, question 11.
Bring it home.
Here is the scenario. A large enterprise heavily relies on Microsoft Configuration Manager, traditionally known as SCCM, for all endpoint administration. They want to gradually shift specific workloads, such as Windows updates and compliance policies, to Intune over time. They absolutely require a phased transition rather than a massive rip-and-replace migration. What is the specific architectural state that allows this transition? Options: A. Windows Autopilot Reset, B. Co-management, C. Subscription activation, or D. Azure Virtual Desktop.
The correct answer is B, co-management. This represents the pragmatic reality of enterprise architecture. Microsoft's endpoint management strategy is not an ultimatum, it is a bridge. To understand co-management, we have to look at the agent architecture on the endpoint itself.
Right, because historically, you could only have one master. If a device had the SCCM client installed, SCCM was the absolute authority.
Exactly. If you tried to enroll an SCCM-managed device into Intune without co-management, the systems would conflict, policies would overwrite each other, and the device state would become unpredictable. Co-management solves this by allowing a single Windows device to be concurrently managed by both the on-premises configuration manager client and the cloud-based Intune management extension agent. They achieve this concurrency through a mechanism called workload sliders.
Explain how those sliders function from an administrative perspective.
In the Configuration Manager console, there is a dedicated co-management configuration node. Inside that node, the various administrative responsibilities are broken down into distinct workloads, things like endpoint protection, client apps, Windows update policies, and compliance policies. Beside each workload is a literal slider. When the slider is set to Configuration Manager, the SCCM client enforces the policy locally, and the Intune agent essentially stands down and ignores that specific category.
So how does the phased migration actually occur?
Let's say the enterprise wants to modernize their patching strategy. They want to move away from downloading gigabytes of update packages to local servers and instead use Intune's modern Windows Update for business rings. The architect goes into the console, grabs the slider for Windows Update policies, and slides it over to Intune.
What happens under the hood at that moment?
The SCCM client receives a policy update instructing it to relinquish authority over the local Windows Update registry keys. Simultaneously, the Intune agent detects that it is now the authoritative source for updates. It applies the Intune update rings, and the device begins pulling patches directly from the Microsoft Cloud. The beauty is that SCCM is still handling the complex legacy Win32 application deployments, while Intune handles the updates. A few months later, the organization can slide the compliance policies workload over to Intune to enable that zero-trust conditional access we just discussed. They migrate workload by workload at their own pace, significantly mitigating risk.
It is a phenomenal migration strategy. Let's briefly invalidate the other options. Option A, Autopilot Reset, is a deployment command that scrubs the device back to the OBE state. It is not a migration topology. Option C, subscription activation, as we established earlier, is a silent licensing step-up mechanism. And option D, Azure Virtual Desktop.
AVD is an infrastructure architecture. It involves hosting Windows client operating systems on virtual machines running in Azure data centers, allowing users to remote into them. While AVD session hosts can certainly be managed by Intune, the technology itself does not facilitate the migration of management authority from an on-premises SCCM server to the cloud. Co-management is the only correct answer.
And with that, we have completed the architecture teardown. 11 complex scenarios spanning the entire endpoint management lifecycle.
Let's quickly synthesize the core architectural pillars we've established today. First, identity. It all begins with the Entra ID cryptographic trust. Understanding the strict boundary between an Entra-joined corporate asset and an Entra-registered BYOD asset dictates your entire downstream management strategy. Second, lifecycle and provisioning. Whether you are navigating the legacy WIM files of MDT thin images or enforcing a secure cloud-native deployment using the Autopilot Enrollment status page, the goal is administrative efficiency and immediate security. Third, hardening. We examine the critical need to automate local credential rotation with LAPS, standardizing the OS posture with security baselines, and protecting organizational data on unmanaged hardware using the encrypted sandboxing of MAM app protection policies. And finally, access. The elegant decoupled synergy of Intune compliance policies defining the health state and Entra ID conditional access enforcing the perimeter, all while utilizing co-management to slowly bridge the legacy infrastructure into the modern era.
When you look at the syllabus holistically, it isn't just a list of disparate tools. It is a highly integrated mesh designed to verify identity, ensure device health, and grant least privilege access, regardless of where the user is physically located.
As we wrap up this bonus episode in the study room, I want to leave you with a forward-looking architectural thought. We have spent this time analyzing how administrators manually configure deployment rings, set up baseline conflict resolutions, and adjust workload sliders. But we are rapidly approaching an inflection point where artificial intelligence and machine learning telemetry will begin abstracting those manual toggles. Imagine an architecture where the Intune advanced analytics engine detects anomalous user behavior, perhaps typing cadence changes or an unusual volume of files being accessed, and the system dynamically in real time shifts the conditional access requirements, forcing a biometric reauthentication, or dynamically pushing a stricter app protection policy to the endpoint without an administrator ever receiving an alert.
The transition from static rules to dynamic, autonomous policy enforcement.
Exactly. The role of the endpoint administrator is evolving. You are no longer just an operator pulling levers and packaging software. You are becoming a boundary architect, designing the parameters and the fail-safes that these automated systems will operate within. The technical mechanics will change, but the foundational principles of identity, security, and access that we discussed today will remain the bedrock of the profession.
It is a complex landscape, but mastering these architectures is incredibly rewarding.
Before we officially sign off, I need to remind you of our final disclaimer. This episode is a study aid, not official exam guidance. Always verify important details against the latest Microsoft documentation.
And on a personal note, we want to take a moment to thank another podcast for our inspiration. Please check out the Startup Chronicles podcast with Kyle Law and Megan Flores. They gave our producer confidence to make this podcast with AI host, and we owe them a shout out. The Startup Chronicles can be found on YouTube, Apple Podcasts, and Spotify.
Thank you so much for joining us in the admin study room today. Keep analyzing those architectures, keep questioning the default settings, and keep pushing your understanding of the modern endpoint ecosystem. We will see you next time.